Hey guys, welcome back. Today we're going to expand upon our hit reactions in this hit reactions part 2 video, and specifically we're going to take a look at the dot product. This is a fundamental formula in 3D games, and there's a lot of uses for it, so you're definitely going to want to understand this one. I'm going to try my best to explain what it is, how it works, and how we can use it. So let's first take a look at the formula itself. We're going to look at the geometric formula here. And so what you have is vector A dot vector B is equal to the magnitude of A times the magnitude of B times cosine of the angle between the vectors. Okay? Now in our case, we're going to be working with unit vectors. Unit vectors in this case are always 1 unit long. Units in UE4 is centimeters. Now what that's going to let us do is that the magnitude or length of A is 1 because it's a unit vector, and the magnitude of vector B, because it's a unit vector, is also 1. Well, what happens when we times something 1 times cosine theta? The 1's go away. And this is great. So it means that we end up with vector A dot product vector B is equal to cosine theta. Which means that if we solve for theta, we get theta equals the inverse cosine, often called arc cosine. And so the theta equals the arc cosine of A dot B, right? Because we're doing inverse. So that allows us to solve for theta, which is what we want to do in this case, because what we generally use the dot product for is to ask the question, how much is vector B going in the same direction as vector A, right? And this is really useful because we can do a really quick comparison between the two. And that's what we're going to be using it for in the hit reaction. So let's take a look at the unit circle here. And let's assume that vector A goes from 0 here to 0, 1, right? So we're going straight up, straight forward. We'll call this the forward vector. And we can, in our hit reaction, we can think of the center here as the center of our actor facing forward. Okay? That's vector A. That's vector A. Now, if we take the dot product of vector A dot vector B, what it's going to tell us is how much is B moving in the same direction as A. Now the range of this function is between -1, meaning it's going exactly in the opposite direction of A, or it's 1, it's going completely in the same direction as A, which in this case, unit vectors, it means it's the same unit vector. So if A is pointed forward, and B is pointed exactly forward as well, the dot product of A, B is 1. Okay? And we'll go around. We'll go around the unit circle. So as we have, A is going straight forward, but now as we move from here along the curve down to here, it goes from 1 down to 0. Because if it's pointing perpendicular to A, okay, if B is pointing perpendicular to A, then it's neither going in the same direction as A or in the opposite direction of A, and therefore it's 0. So it's 1 here, it's 0 here, it's -1 here because it's going the opposite direction, and it's 0 again here. Okay? Now what that's going to help us do is actually cut this into, there's an X being drawn between this, because what we're going to ask is, we're going to do the dot product of the forward vector, okay, of B against A, and then we're going to do the dot product of the right vector against A, and we're going to ask which one's bigger, okay? Here's why this is going to work. At this point, 45 degrees in between, right here, is the point at which the forward vector dot product against the forward vector is going to be larger up until this point, right? But at this point right here, now the right vector is going to be larger. You see what we're doing here? Same thing here. It's going to switch here, it's going to switch here, it's going to switch here. And we're going to use that to be able to figure out which direction we're being hit from by taking the vector, our own forward vector, and then comparing it against the forward vector and the right vector of the person attacking us. Okay? And so one of the reasons we have to do two of them, we can't just do one, is because, remember what I said, the forward vector, this is equal to 1, this is equal to 0, this is equal to -1, this is equal to 0. So we can tell the difference between a forward and backward, but we wouldn't be able to tell the difference between a left or a right hit because both of the values will return 0. And if we get 0 back, well then how do we know if we got hit from the right or the left? But if we do it with the forward vector and also with the right vector is going to return 0 here, or I'm sorry, 1 here, 0 here, -1 here, 0 here. You see? So by using the two together, we'll be able to split this thing into an X and determine whether it's in this area, this area, this area, or this area. Okay? So we're going to program that. So I've gone here and downloaded part 43.2, and I've extracted it. I've set it up following these instructions, and I've created the solution, and I've opened the solution. So let's get started right away. We're going to make a C++ function to help us figure out the dot product. Print callable. Category, we're going to put it in hit reaction. Okay, you could return an enum here. It might make the code more readable. I'm going to go for simplicity, and I'm going to return an int. Get hit reaction direction. Now we want to send in the AOWS character pointer, because this is what we have, of the attacker. It's getting called on the person being attacked, so we already have that. Going to copy this, and we're going to go over to our CPP file, and we're going to paste that in. We're going to grab the namespace. Okay, and we're going to start implementing. Okay, we are sending in a pointer. We do not know if this pointer is good. It may be null. If it's null and we try to do something with it, we will crash to desktop. Therefore, we will make sure that the attacker, this here is saying if the attacker is null, right? So if we were to do this, it would say, hey, if it's good, if the pointer is good, this is saying the pointer is not good. We're going to return 0. So I'm actually going to put a legend here. 1 is going to be equal to forward, 2 to right. This is where you could create an enum if you wanted to, but I think it's overkill. And 4 is equal to left. And I guess 0 is unknown. There's some kind of error. Okay, so now what we want to do is we want to check, remember we said we're going to do a forward vector comparison. And the function we're going to be using here is fvector namespace. And it's a static method. And we're also going to be doing a right vector comparison. And we can get actor forward vector. So we're going to be using the actor forward vector here of ourselves, and we're going to be comparing it to the attacker. And I'm copying and pasting the actor forward vector. Somebody's shooting fireworks off outside. Pretty loud. Okay, so in this case, we're going to keep the forward vector of the attacker, but we want to know how it relates to our right vector. So I actually made the mistake the first time of using the right vector here and the right vector here. And that will not work. That will not work. You'll end up getting the same value both, because if you create an orthogonal system with your forward and right vectors, if the forward vector is a certain dot product with a forward vector, the right vector is always going to be the exact same dot product. So don't do that. Make sure that the attacker always uses the forward vector, and for ourselves being attacked, we do a comparison with the forward vector, and we do a comparison with the right vector, and this is what will give us what we're looking for. Okay, now what we want to do is we want to ask the question, is the forward vector greater than the right vector? However, that is actually not good enough. We actually don't want to know if the scalar value returned, remember it can go -1 to 1. We actually want to ask if the absolute value. So we're going to use fmath ABS. Okay, and so what this means is that if it falls into this first if, it means that one of two things is true. Either we're being hit from the front or hit from the back. Okay, that's forward, backward. So that means the else statement that it falls into is going to be right/left. Okay? Now then we need to narrow it down within each one of these. So we know that if it fell into this, it's forward or backward, but we don't know if it's forward or backward. So then the question we will ask is the forward vector comparison greater than 0? Okay? And we're going to do the same type of thing down here, except we're going to use the right vector comparison. Now, there's a bit of, we have to flip things a little bit, okay? Because we actually want to do backwards of what would normally be the case. Because remember that if we're facing forward, okay, and the attacker is facing the same direction as us and they hit us, that's not a forward hit. That's a backward hit. Because for them to be facing the same direction as us and hit us means they hit us from the back, right? So everything is in reverse. So in this case, the forward vector comparison greater than 0 means front, but we need to return back. So we can refer to our legend up here. Otherwise, we return forward. So we're flipping them here so that we don't have to flip them later. Same with the right vector comparison greater than 0. It would normally be right, but again, we have to flip things because of the alternate direction, because two vectors going the same direction is opposite, just in the case of hit reactions, right? Because of what we call them. It's a bit confusing because we're not saying are we hit from the front, right, or there's a difference between the direction we're hit from and the direction we're knocked away from, right? And so we're just reversing them here so that they'll match the UE4 animations that we already have. Okay, so we're going to return 4, and we're going to return 2. Okay, so what this method is going to do is we're going to be able to send it the attacker, do the dot product comparison, look at the result, and return either forward, right, back, or left, so we know which one to play. And let's compile it. I think we got everything right. It's just recompiling the plugin. It's normal. There we go. You'll notice that there's actually another spot we used the dot product, and it was in our animation blueprint where we wanted to ask the question, is the direction we're moving more along the forward-backward axis, or is it more along the left-right? And so we did this same kind of forward vector comparison and right vector comparison to determine whether we're strafing or whether we're moving forward and backward. So that's one other spot you'll see it. It can also, the dot product, it can be used as a cheap way to calculate the cosine of the angle, because remember, one of the things that you were solving for was cosine. And so it's one way to do that. That's historically, that's a large use of dot products in 3D graphics. But there's a lot of uses. To very useful formula to do angle comparisons, and it's fairly cheap. Okay. So what we want to do now is we want to go into our blueprint, and there's another error I wanted to show you. A spelling error, actually. So if I go into our base character, you remember that last time we created this, I spelled right, W-R-I-T-E, and no one in the comments pointed it out. Anyway, I'm joking. We're going to go fix that because that bothered me. So we're going to come down here, and it's not that kind of right. It's this kind of right. So we're going to fix that. We hadn't used it for anything yet, so it's not going to throw an error. If you do change C++ and a blueprint still referencing it, you will often get a blueprint that you cannot open and cannot fix. And so you got to be careful about that one. But in this case, I know that we did not use it, so we're safe to do it. Otherwise, I would have gone and removed any references to it before making that change. So now we should see that it's done right here. So remember that this is our grant-based default abilities, and right now we're only granting the hit reaction front. Let's go grant all of those. Let's pull these underneath here. Remember that this is in the base class, but most of the time we're not going to be setting them in the base class. We're setting them in the derived class, but this is the reason here. Get hit reaction front back. What we're basically saying is here, hey, whatever's in that slot, grant that. We don't know what it's going to be. And so we're keeping it dynamic. Reaction left. And hit reaction. Doing this first because for some reason 99% of the time when one of my gameplay abilities doesn't work, it's because I forgot to grant it. Okay, so now we got the granting working there. We're going to go back to the event graph, and you remember that we got this on take damage, and remember we've got this who attacked me. So we're going to move this over, give ourselves some room, and remember that we added a new function back here. Oops. Called get hit reaction direction. We're going to come back over here. We're going to do get hit reaction direction. And we have who attacked me. We're going to drag that to attacker. Okay. So that's actually going to output an int, remember? And what we want to use, we're going to disconnect this because we're going to make it dynamic. And what we want to use is a switch. I'm sorry, select. Select is going to be easier. So we'll drag this, oops, not that. We'll drag the integer into this. And as soon as we drag this into the type, it's automatically going to dynamically switch that type. So what this will let us do going to need some more room, is that we will be able to add, remember, types 0 through 4. 2, 3, 4. Okay, so hit reaction front. And I'm going to actually drag this into 0 and 1. Basically what's happening here is that 0 is that, hey, the attacker's null, we don't know what's happening. For now, we're just going to say, okay, play the hit reaction as if we got hit from the front. We could also have some kind of if here that said, hey, if it's 0, don't do anything. We'll have to see what works good there, but for now I'm going to plug that into both. Okay, remember that we need to go back and reference. Yeah, oh, I did not mean to do that. Yeah. Anyway, we need to go back and reference this here. So 1 is forward, 2 is right, 3 is back, 4 is left. So right, back, left. Okay. Go here. Reaction. What's happening here, the way I did it, is that we're kind of going around the unit circle. Front, right, back, left. So we're going around the unit circle. Hit reaction back. And number 4 is going to be hit reaction left. Okay, so now that code in the base class is looking pretty good. Now I got to move over to our actual player character. And what we want to do is we want to set these. But remember, we only ever built the front one. So I'm going to hit this to go to that folder. And we need to duplicate this. Back. And we'll duplicate it again. Back, left. And we'll duplicate it again and do right. Okay. So now what we want to do is go into this back one. And this is what we would want to edit. Okay, so we haven't created this anim montages yet, so we'll hit that to go to the folder. And notice that we only have anim montage front, so we want to duplicate this. Back. And we'll duplicate it again for left. And we'll duplicate it again for right. Okay, so we're going to open up one of these. And we're going to look for hit. And we want to make sure that it's in the right folder. We moved them in the previous one, so see they're connected to the Seraph AMs under MMO rather than under Seraph. So we're good to go. So we can look up here and see that this is back. And so we can also see the star next to it here. We drag the back one. Okay, and this is back here. Now we choose the back one here. Okay, so we'll move on to the next one. We got front, back, left. Delete this. We'll type hit. And we pull the left one in. And we'll go to the right one. Typing hit, and we pull the right one. Okay, and now we need to go back to our gameplay abilities, hit reactions, nope, hit reactions, and we did front and back, we need to do left, left, now that we have those, we can now assign them here and wire them up. Back, left, right. Okay, so now we can load our world, hoping that derived data cache means I don't have to rebuild the shaders. Good. Otherwise I'd be pausing the video. Okay, so now let's give it a try. Remember, we've got to change this play offline to play as client. Every time you copy the project, move the project, rename the project, any of that, you're going to lose it. So make sure it's play as client, otherwise it's not going to work. It's probably going to be nighttime too. Oh, what did we do here? Hold on. I saw that it failed. So what I think is happening here is that I forgot to configure. I'll save those. I believe I forgot to configure this config file. I did. See, no customer key. So I'm actually going to go over to test one I used. I had blanked out the customer key so that I could upload the copy online, and I never put it back. So this is where you would put your API key. And we should be all good. I'm going to start it back up. Yeah, anytime you see yourself have 0 health and just die instantly, that's usually a sign that it's calling out to the API to try to get how much health you have. It's like, I can't find your character, I can't find your API key, or I can't find something. And so it pulls back 0 and kills you instantly. And so it's a good way to know something's wrong there. Let's give it a try again. Make sure play as client. That's more what we're looking for. And as always, it's nighttime. It always is. Better time. I was trying to type time. Time of day. 7200, so I just go put half of that, and it'll be the opposite time of day. I'll hit play. Okay. Zoom out a little bit so we can get a good view to see which way we're being hit. So what we want to check is to make sure that when it hits us, okay, that's good. Okay, that's good. That's good. Look at that. And now it's pushing us the direction away from it. And this is because it's calculating the dot product. You can see right at about there is where it would flip. So we go a little bit more. Yep, see, it goes there. So it's at those 45 degree points that it's going to flip. Very cool. So now we're able to use the dot product to determine which direction we're being hit from. So one of the things that we're doing currently, is not a great idea, but I did it for simplicity to get this started, is actually in our BP. So one of the things we'll be changing in the future is that this is not ideal. You see the problem here? Event on take damage, play hit reaction, right? That's not a great idea because we lost the scope, right? We lost the scope. We don't know what kind of hit is this. Is it a melee hit? Is it a ranged hit? Would you really want it so that every time a dot damage over time ticks against you, it tries to play this? Which is also when the attacker's probably going to be empty, by the way. So what we will be doing in the future is we will be taking this code and actually moving it into a way that we can tie it to the game playability itself and use tags to control it. So that's what we'll be doing in the future. But for now, hopefully you have a better idea of the dot product and how it helps us understand when we have vector A and vector B, how much is vector B pointing in the same direction as vector A. 1 is it's pointing in the same direction, -1 is it's completely opposite, and between 1 and -1, is the amount that it is in between, and if it's perpendicular, it's not pointing in any direction. B is not pointing in any direction of A, and so it's going to be 0. It's pointing directly to the left or directly to the right. So I hope that helps, and until next time, see ya.